Hey everyone, my name is Kevin Vandenberg and I'm with Wallace Ennis Associates, and thank you for joining me on another Wallace Ennis Tech Talk. Today we'll be talking quickly about air control for your system. So a little bit about Wallace Ennis from the previous episodes that you have seen is Wallace Ennis has been in business now going on 96 years. We have about 72 employees. The average tenure that we have right now with the amount of people in Wallace Ennis is about 16 years. We have two locations. One location is in Franklin Lakes, New Jersey, where we have the capability of building pumps. We have two lathes. We can do up to 25 horsepower. We also have a wide variety of warehousing needs, from circulator pumps to expansion tanks, stock air separators, stock heat exchangers. And then in the Plainview, Long Island office is the same thing. We have office staff on hand that will be able to do inside sales support for you guys, full-time engineers to be able to calculate pump requirements, building requirements, as well as storage inventory. We maintain about $3 to $5 million worth of inventory in each warehouse. So we are fully staffed and fully prepared to meet every project's needs. Let's begin with the Wallace Ennis 360 experience. When we talk about a 360 experience, is we cover the full spectrum from the start to the beginning of a project. We have our full-time engineers on staff that work directly with the engineers. So they would be in the beginning phases where they would size the equipment, lay out the project, talk to the engineers. The engineers would then relay their information to our engineers to calculate and size the pumps that are needed, the boilers size based off the BTUs and so forth and so forth. And then we go to the building owner. We talk with the building owner, we get their approval, we do everything along that line. Then we get to the contractor. We speak with the contractor, we work with the contractor, making sure that the equipment is correct. It meets every aspect of the specification. And then we also work with the general contractors to make sure that they are on board and they know what they are getting, and we meet all of their expectations. And then lastly, we go back to the building owners and the operators. We discuss with them to make sure we meet every need. We've met everything, as well as offer them extended care packages for their system. So our first category of Wallace Ennis, we call it the Hydro Source. The Hydro Source is our standard plan and spec. This is where our engineers start in the beginning with the engineers, and then we work through the process all the way to the contractor. Then we have the Hydro Max. The Hydro Max is specifically for the after sale, where we would work with the building owners for heat exchanger cleanings, preventative maintenance, remote monitoring, startup commissioning, and so forth. Then we have Hydro Fab. The Hydro Fab is the Tisdale Manufacturing sister company of Wallace Ennis, where we do a lot of prefab skid packages. That has been the growing fab now in the industry to meet time demands, especially with what's going on in today's world with COVID-19. You know, we had that couple months setback, and that was a lot of time lost. So to be able to pick up time and speed, it's become the standard now to skid mount stuff, where the headers of the pumps, the boilers, everything will be on drop and play with a single point connection from the headers to the electric wise. So it's really worthwhile, something for people to look into. And then we have our manufacturing partners, a long list of manufacturing partners. Dead center again is our sister company, Tisdale Manufacturing. Above that, we have Lochinvar Boilers. And then we also have our flagship product, which is Bell & Gossett, pumps, heat exchangers, air separators, expansion tanks. We also have now gotten into the air side of things, where we have Panasonic VRF, mini splits, and so forth. Project spotlight for us, I mean, gosh, there's so many projects throughout New York City. But, you know, one of the big ones recently is One Wall Street. We have a lot of equipment going on there. 2865 Bedford Greenhouses was a small project where we skid mounted the pumps, the boilers, the expansion tanks. 99 Hudson was in Jersey City. We have 22 skids. And I repeat, 22 skids that went on this job. We worked directly with the general contractor on this. And then worked with the actual mechanical contract. The project was a huge success for us, as well as the cost savings and time demand on the project. So back to our main topic that we're talking today is air control in a system. So when you look at a system and you start thinking about air, you start figuring out that you need something, right? You need something to eliminate the air in an open system or even a closed loop system, right? Not so much the open air one because that's constantly going, but in a closed loop system, the air in the system is detrimental. It can really hurt the system, hurt your system efficiencies. So we'll quickly talk about it, and hopefully it'll give you a quick idea of what's needed. So 3 main issues that with entrapped air in a system it will cause is 1 is reduced efficiency, 2 is excessive wear in your system and equipment, and 3 is excessive noise. So when we say excessive noise, you're talking about air trapped in a system, excessive wear in your system, you're talking air will corrode piping, air on 90-degree elbows or 45-degree elbows. That's usually the first spot that you see air will start hurting because that's a turn, right? So that's causing that turbulence in there, and for that water to move, and it's making those air bubbles hit up against the steel, and so it causes a huge issue for it. So how do we handle air in a system? There's 2 specific ways that realistically you look at and you say, 1 is you're forcing the water, right, to go to certain patterns. 2 is pressure, and pressure meaning, how do we deal with the expansion and contraction, right? Forcing it means that we're going to force it somewhere for that oxygen to dissolve somewhere. So the first item that we'll talk about is air separators. And air separators is the way for us to eliminate air. And the air separator uses water for it to come in, and it comes through each inlet, and it goes through a very tight channel or a nozzle, and the connections that create a swirling vortex effect in the center of the unit. So that water in this picture, you'll see it comes in the inlet, it swirls around, the air bubbles then come out the top, and it goes right up to the vent, and the vent allows the air to come out, your water goes down to your system. Now, when you talk about sizing an air separator, it could be a couple different ways. If it's undersized, it may take a couple passes for water to eliminate, oxygen. So it's always important to make sure that when you have an air separator system, it's sized appropriately, and that's what we're here for at Wallace Ennis. So some types of air separators, there's 2 that we really focus on. 1 is the standard tangential air separator, which is just your removal of air. The second one you're starting to see become more popular, which is the coalescent, and that's a combination air and dirt removal. There's pros and cons to both. That could be separated for a different day, but these are the 2 that you're going to look at. So on the bottom left is your standard air separator, your tangential air separator. The bottom right shows you what the coalescing is. So installation on an air separator, the best place to locate an air separator is where the water temperature is high and the pressure is low. So best practice, again, on the heating system is right outside the outlet of the heating source. On the chilled water, you kind of want to see it, in the return back to the chillers. So again, now we talk about expansion. So how do we handle air in a system? As far as now we're talking about pressure, right? We're talking expansion. And when you look at that, you really need an expansion tank because that water is heating up and it's cooling down and you're having that contraction, but you're expanding that water. You need it for it to go somewhere. So expansion tanks are needed in a closed loop heating or chilled water system to absorb expanding fluid and limit the pressure within a heating or cooling system. And 2, expansion tanks use pressurized air to maintain system pressures by accepting and expelling the changing volume of the water as it heats and cools. So, you need it to go somewhere, right? So that's what the expansion tank is. Now we have 2 types of expansion tanks that are commonly used, right? And there technically could be 3 because you have the old school compression tanks, but nowadays we're seeing 1 of 2 types, right? On larger systems, you're really going to see a bladder tank, which uses a heavy duty bladder to absorb water into the tank. And the other one on the smaller systems, you're going to see a rubber diaphragm tank, and both have their pros and cons, right? Primarily, the bladder tank's going to be more money, but it's more efficient of a tank. You can change the bladder down the road, where the diaphragm tank kind of looks like a Snapple cap when you in the inside, where you reverse that half Snapple cap and it makes that popping noise. It pushes back and then it clips back. Be able to go back. Bladder tank, again, is that a bladder in there is like a giant balloon. If you were to put a balloon on a hose or a faucet, how it fills up and goes in there. So you can get a lot of full acceptance in that bladder tank. So you'll be able to do that. So your system could be a little bit more efficient. In the diaphragm tank, you have some limitations. So you have certain acceptance volumes to it. So, you know, the main question for us, obviously, is the expansion tank installation and the charging. So the best place to install the bladder expansion tanks or even the diaphragms just before the section side of the pumps in the hot water boiler system or hydronic loop, because the fact is that you got return water, you got everything you need that's coming back. So that expansion tank can really work well for that system and make it run better. Then again, you know, you can put an expansion tank in certain places, but just be mindful. Charging the expansion tank, there's a threaded connection at the top. You literally can put a bicycle pump on there. You can pump it up and make sure that it meets your need. The other question that we constantly see is, what should I charge my expansion tank for? So probably a properly sized expansion tank and charge tank should be keep the system pressure about 5 psi lower than the pressure relief valve in the system at a maximum operating temperature, right? So there's a lot of things, there's some formulas to it, but you know, again, you can contact Wallace Ennis, we can come in, we can talk and sit down about how to accurate size that expansion tank, but you know, you want to be able to do that. So again, thank you for your time. I hope this really hits some ideas for you guys and sparks your interest to be able to contact Wallace Ennis and realistically let us help you size your project and we can work for you.